Hello, everyone, and welcome to Agulhas Current Affairs, a marine science podcast set in Southern Africa with me as one of your hosts, Dr. Jens Giston of Geekoscopy Media, alongside
Dr. Nelson Miranda of Argonaut Science. And today we are getting extreme again. We're talking about heat waves in the ocean waves.
the ocean waves. They also happen there, Nelson.
Hello, that's what we're going to discover. We're going to, you see, we don't notice these things, Whenever there are extreme events talked about in the general news, we think about heat waves on land, isn't it? We think about the very high temperatures, all that we experiencing all over the world. We're thinking about fires that are happening. We're thinking about frying eggs on, unusual surfaces.
Exactly.
But what about what's happening in the oceans? I don't think we think about that or we notice it as much, isn't it?
Yeah, especially if it doesn't have a massive visual component to it, like coral bleaching, where you can see what's happening, but not every heat wave results in something that sometimes it is maybe happening on a lower scale, or it might be affecting organisms that you don't think about in your day-to-day life. So
yeah, after all, on land there's these huge temperature variations, so that you can actually fry an egg. But if you try to do the same thing in the ocean, the variations are only a couple of degrees of temperature. So it's not quite enough to boil the egg in the water, is it?
Yeah, that's why there's no viral videos about it. Yeah.
Probably not.
Yeah.
But it still may be, an important, that could be a big impact of these things, isn't it? But even have you noticed though that we as human beings are very adaptable? So whenever these heat waves happen, we sort of pay attention to them and we talk about it, and then later we actually forget about it, isn't it?
Yeah. I mean, just recently, earlier this year, there were crazy heat waves happening in Europe, and that stirred a lot of trouble and drama, and definitely at that point the climate change kind of idea was spreading. But then now it's quiet again, at least on that front. We do although have COP27 happening now, which is a different story. But it is one of those things where when it's happening, there's a lot of attention and everyone knows about it. But a week later, it is gone and it is quiet and you don't see anything.
Yeah, I mean, we're generalizing, obviously, that a lot of people are affected directly by these things, and it's hard to forget. But in general terms, we tend to forget about these things. And how much more forgettable would it be if it happened in the water and there's only a small little change in a few degrees of temperature, isn't it?
Yeah, exactly.
I mean,
the problem with that is that it builds up over time, so it gets worse and worse.
So these let's call them these events, they are happening, more often. And that's definitely linked to the trends in climate change, the way the climate is changing. And it's interesting because, these events are definitely happening in the ocean. And how do we know? Well, we measured it. We use satellites that are orbiting our planet. Those satellites are picking up information of the surface temperature in the oceans around the world. And we've definitely picked up some very obvious areas around the world where there have been, marine heat waves, right? But did you know that we've also picked up such heat waves right here in around the Agulhas Current region, right here in South Africa?
Oh, dear, right at home.
Right at home. We actually have picked it up, and it's interesting because, even when it comes to the information on marine heat waves, there's a lot more information available for elsewhere in the world, but not so much for around Africa. Perhaps because there's a general... I wonder if it's because people think that Africa is just hot anyway, so what's the difference?
It's just hot. Yeah. I mean, we do describe South Africa as like a semi-arid country. So like in its like weather description, it's very like dry and hot. And yeah, a lot of Africa is dry and hot. But it doesn't mean that it getting hotter isn't a problem. There's ranges where things can live healthily. And once you fall out of those ranges of thermal tolerance, it sometimes can be problems.
That's
and
right.
That changes between species. Like different species will have different tolerances for how much, whether it's heat or whether it's cold, they can take before it changes how they, whether they survive, whether populations survive or move around, and things like that.
Yeah, absolutely. So these events, these heat events may be and are definitely influencing, life that is in the ocean. So, and fishers, for example, might actually notice that when there's these marine heat waves concentrated in certain areas, they'll notice like that there's a response by fish, for example, that can actually move out of those areas. And there's like a disturbance in the usual patterns of where fish move, because even though there's only a couple of degrees difference, perhaps, it does have a general negative impact because the ocean is supposed to be quite buffered in that, there's not these extreme fluctuations in temperature normally, but as they do occur and they become more frequently, then there's a lot of life that can't cope, because they're not really adapted to that, or there's a shift in the communities that kind of like it hot,
Yeah.
and that might not be great for certain fish, so they also move away. And not to mention as well, as water gets hotter, it's harder to breathe. So even if you have gills, as things get, as the heat rises, it's there's less oxygen it can actually get from the water. But anyway, you can actually
undergrad physics, and gaseous exchange. Yeah.
Absolutely, and if you're interested, there maybe we'll link in the description a paper about what is known about extreme thermal events in South Africa, in and around South Africa. They looked at over 40 years of data, more or less, and they picked up some interesting patterns. So not only are there heat waves, marine heat waves in near shore, so very close to our shores, but there's also cold spells. Okay, so there's these fluctuations because our planet is very dynamic, and as currents change, and as the weather itself, as the air heats and cools, that's what kind of drives these these heat waves and cold spells, isn't it? And we really don't know much about it. We need to understand. We've detected them at the large scale, but we need to understand what happens at the smaller scale. What are the impacts of these events on organisms? And if you're wondering, like, what's the, how do we tell whether it's a heat wave or not? There are temperature measurements, right? And then it's been worked out, almost like as a world standard, right? The definition of like an extreme thermal event. So that's a fancy way of saying it, like too hot or too cold in the ocean. So first of all, you set up the historical trend, isn't it? You look at the historical trend because it's almost like an average temperature, right? And then you look at things that vary like a lot away from that average. So when things vary, and then for the extremes, we're talking about out of 100, we're talking about the 90th percentile. So usually we make it out of 10 or out of 100. We put it on a scale of some sort, so that if things are very close to 100 or very close to 0, we know those are the extremes, right? And that's essentially what how you can sort of look at these temperature variation and decide, okay, if something is within that 10% at each extreme of the average temperature fluctuation, then we'll call those extreme events. And that's all being sort of standardized around the world. And it's not just that the temperature sort of goes high or goes low. It needs to stay like that for a number of, well, for a period of time. And we're talking about at least 5 days, so more than 5 days. And wow, there's been sort of heat waves that have lasted weeks and even over a month, right? So these yes, in South Africa. And then the other thing that sort of researchers around the world have worked towards is to compare, like how strong are these events, even by global standards, and the South African heat waves, how severe they are, how bad are they, how extreme within those extremes do they get, And obviously that has to do with how long they persist for, but it also has to do, with the number of degrees of fluctuation that they stay at, So if they stay like 2 degrees, 3 degrees, wow, that's a huge fluctuation. If they stay 3 degrees above, degrees centigrade above, like the average for a long period of time, that's quite extreme. And the South African ones are in the mid ranges, right, by world standards. But that's, that's definitely significant. That's not something to say, oh, they're just in the mid ranges. Okay. No, you need to understand, like, that means it's quite, quite a strong sort of event, and we need to understand what it does.
We're talking about anomalies, it's like in the mid-range of anomalies.
As far as anomaly go, we definitely getting them. It's not like they're in the lower ranges, and they're already an anomaly to start with, And so, like, the real question is now, will we notice it right by the beach, isn't it? Will we notice that? Because there's the heat waves that happen in the water and the heat waves that happen on land. They're kind of linked by the atmosphere. So often when you get a heat wave on land, you're gonna hit the heat wave right there, in the shore. And so to try and understand, what's going on, we actually can study it. There's an interesting project that we're putting together where we're looking at, as you said earlier, the tolerance, how tough is life at the shore. So specifically the rocky shore. So not the sandy beaches. When you go to the shore, we either get sand or we get rock. So we're looking at things that can grab onto rocks and sort of survive. And these things generally in the rocky shore, life that persists in the rocky shore is generally very tough. And particularly what we're interested in are, of course, snails. Tough snails. Because, they have shells, they're already quite tough. They can actually move, even though they can't move too far, right? So they can't escape, but they can find little crevices in the rocks and things, and they can move. So they can actually kind of find ways of sort of surviving some of the more extreme events. And the rocky shore is pretty extreme. If you ever seen, how the waves of the ocean bash into a rocky shore, you have to be pretty tough already to live there. But even so, we expect that these animals, as tough as they are, they will still be impacted by unusual temperatures that are high and stay high for a long time. And we need to understand, or we want to understand, what happens. Do they die? Do they get sluggish, snailish? And that gives us a pretty good idea of how life may adapt, or if life can adapt, and which part of life, which organisms, which kinds of life may be favored by these more extreme events in the future. And this is important because this life also is part of what rocky shores are, and a part of shaping the rocky shores. And some of this life is actually very important to us directly for subsistence, like, the very obvious examples are the mussels on rocky shores. we don't know much about what the impacts of these extreme events might. What are the impacts on life in the rocky shores, on the beach? But we hope to find out more about that, and that work is going to be done here in South Africa.
100%. Which research organizations are involved with that kind of work?
Stellenbosch University. There's a lot of interesting work going on there on climate change, just keep an eye out for that. But
Okay.
there's other work going on as well, and I think it's important for us to not forget about the heat waves that actually exist in the ocean waves.
In the ocean, yeah, exactly. It might be on a different scale than on land, but it doesn't mean it does not happen. It doesn't mean it doesn't have impacts. That's something you want to study. Go speak to Nelson at Argonaut Science, I believe, all over the internet.
Yeah, or I'm sure Janus, because he's an ecophysiologist, as we found out on one of our previous.
You're gonna keep bringing this up, like it's so novel news to you.
With Janus, and check out what he's up to in geekoscopy, which is interesting
media. Yeah, or you can tweet at us at Agulhas Current on Twitter, or at Agulhas Current Affairs everywhere else. Stay in touch. Let us know what you want us to talk about. You want to share about anything.
Yeah.
And until then, it's cheers.
It's cheers. Stay cool or stay hot, depending.
Stay cool or stay hot. That's a good way to end it. I think we should have every podcast like that. Stay cool or stay hot. All right. Cheers, Nelson.
Cheers.